So good evening, everyone. I'm Achini Ramdania, the Secretary, IT and Computer Engineering Sectional Committee of IESL. On behalf of the IT and Computer Engineering Sectional Committee, I would like to welcome you all to the Tech Talk using AI to reduce online misinformation, which will be conducted by Dr. Danula Hettiarachchi. So Dr. Danula Hettiarachchi is a research fellow at RMIT University and works with the Machines program at RC Center of Excellence for Decision Making and Society and RMIT School of Computing Technologies. He has a PhD from the University of Melbourne, where he researched on task assignment using worker cognitive ability and context to improve data quality in crowdsourcing. He graduated from the University of Moratuwa in 2015 with a BSc Engineering degree in Computer Science and Engineering. So now I would like to invite Dr. Danula to conduct the session. Over to you, Dr. Danula.
Thank you, Achini. Let me first thank ISL and Professor Chandana Gamage for inviting me for this talk. And yeah, it's a real privilege to join you guys and talk about this topic. Of course, it's quite a timely topic. We've been hampered by a lot of misinformation, mischaps lately. So hello everyone. I'm Danula Hettiarachchi. So as Achini mentioned, I'm a research fellow at the RC Center of Excellence for Automated Decision Making and Society, and the RMIT School of Computing Technologies. So today I'm going to talk about using AI to reduce online misinformation. And before I jump into the talk, I want to talk a little bit about the center that I'm working in. So the ARC Center of Excellence for Automated Decision Making and Society is a national research center in Australia. Here we are looking at how to create responsible, ethical, and inclusive automated decision-making systems, particularly by bringing in experts from different subject areas. So we have lawyers, social scientists, communication experts working alongside computer scientists to tackle these problems. And we are looking at different research areas like news and media, transport and mobility, and health under different dimensions like data, machines, institute, and people. And I work with the machines program, so I'm representing the computer science researchers in this center. Just a bit about myself as well. So I did my bachelor's in computer science and engineering at the University of Moratuwa, and of course followed by my PhD at the University of Melbourne, where I looked at crowdsourcing and how we can effectively collect high quality annotations in this kind of crowdsourcing setup. This is not what I'm going to talk about today, though. I'm mostly talking about my research at the ADMS Center and the RMIT School of Computing Technologies, which mainly looks at responsible AI, online misinformation, and social computing space. But I've done quite a bit of research in human computer interaction space as well. I'm particularly interested about how people interact with systems. So basically, like how humans interact with automated decision-making systems, and trying to characterize this interaction, understand how different attributes and different biases influence the system outcomes and the input that the users provide. I'll talk a bit more about this as I go on with the talk. I'm talking about a bunch of studies that we have done, and I'm also kind of alluding to some latest research that other people have done. And in each of these slides, you'll find a reference to some of these papers. So if you want to learn a bit more about this research, feel free to read through those papers. And I'm also happy to answer questions as I go on with the talk. So let's start by looking at what is misinformation. So in a very simple definition, so I just got this definition from the American Psychological Association, where we use the APA citation style. Misinformation is defined as false or inaccurate information. So this is very simple, like getting the facts wrong. You tell something that's not accurate. And then there's a slight variation of misinformation that is what we call disinformation. So the disinformation is false information, but in the case of disinformation, you're deliberately trying to mislead someone. So you're intentionally misstating the facts. So now think about a statement made by a politician in the parliament, or when in a public forum. They might tell you of a number or a figure. Let's say they're talking about the GDP and the GDP growth over the past 5 years, and they might say that it's 5% or 5.2%. And they might state this without knowing the exact figure because they didn't have time to look up the facts and whatnot. Right? So in that case, that's misinformation because that might not be the accurate information, but they're not deliberately trying to misrepresent a fact. But let's say they're talking about some sort of a project which has gone above the budget, and they might mention in a public forum that the project was within the budget, and then they might say that, let's say, the project was for 2 million, whereas the actual expenditure is 3 million. Now, in that case, this politician is intentionally trying to mislead the audience or the public by hiding the fact that hiding the actual information about the actual cost. So in that case, that becomes disinformation. Now, why we really want to study misinformation, and why do we really want to reduce misinformation in an online context? Well, misinformation comes with its costs. So COVID-19 is a very good example where online misinformation went rampant across the globe. And so here you can see a piece of news from CBC, which is from Canada, and they have estimated that COVID-19 misinformation has actually cost at least 2,800 lives and 300 million Canadian dollars. So just as a contextualization, so people following misinformation, they might not get the proper treatment, so they end up in the hospital and they end up losing their lives as well. So misinformation can be really costly in an online context. So the research that we can do to understand and prevent misinformation online is really valuable. So before we dive into how we can use AI to reduce online misinformation, let's talk a little bit about different types of misinformation. Now, there are so many types of misinformation, but just by going through these, we can get an understanding about what misinformation is. So the first type that we can think of is fabricated content. Now, this is like completely false content. Now, think about you writing a hypothetical news article without knowing any of the facts. So this is fabricated content. You're writing something from the scratch. And then you have manipulated content. Now, this manipulated content is like genuine information or images that has been slightly modified or distorted. So think about you getting an original photo and then kind of using Photoshop to manipulate it a little bit. So that's kind of manipulated. Or you reporting about an event with a really clickbaity kind of headline, which kind of tries to manipulate the reader and tries to draw them into the content. The third type is imposter content. So in imposter content, the creator is trying to impersonate a genuine source, right? Think about one of the main media outlets in Sri Lanka, let's say Rupawahini. So let's say there's a YouTube channel that tries to use the Rupawahini logo and pretend to be the Rupawahini YouTube channel, right? So that's imposter content. And then you have misleading content. So the misleading content is like a misleading information that is presented as a fact. So you can think of quoting a professor or someone and then presenting it as a fact, whereas it's just an opinion coming from that professor. And then you have false content, false context. So in this case, so you're actually presenting factually accurate content, but you're trying to mix up with the false context, right? So think about an article, a news article that doesn't have the accurate title. So you have like a completely different title, which doesn't really reflect the content that it has. So then it's like kind of false context, because your actual article is correct, but then the headline itself is not giving the accurate information. And then the next one, the satire and parody. So this is also quite interesting because you might have seen this stuff in YouTube. So this is just to create humor, right? So you might have seen impersonation of famous characters, even like US Prime Minister, the US President, or there's content that has to do with kind of Australian Prime Minister. So you're trying to create content to, for fun, right? So, but then some people might actually look at it and they might think, oh, this is a statement made by this particular person. That's not true, but that essentially falls under mis or disinformation as well. And then false connections. So this is again similar to kind of false context, but in this case, you're trying to use visual or captions that do not really support the content. And then you have sponsored content. This is some corporation or a company trying to disguise as authentic or original content. So think about Google search. When you try to search for an article or when you try to search for a particular news item, you might see advertisements on the top. But in the case of Google, Google clearly says this is sponsored content, right? But if you remove that label, then it's actually misleading, because then the sponsored content is being presented as authentic content. And then we have propaganda. Now, this is more like a campaign run by an organization that uses misinformation to kind of drive certain values and knowledge. And then finally, we have errors. So that's kind of a mistake made by a particular news agency. You can often see in kind of newspapers, sometimes they make a mistake about a number or about a particular statement, and they might issue a correction later saying that, look, we've made a mistake. Now, all these different types of content actually fits within mis and disinformation. For the convenience during this talk, I'll just refer to them as I'll use an umbrella term and refer to them as misinformation. Okay, so let's get into the content. How can we use AI to reduce online misinformation, right? So I'm going to break my talk into 3 parts. So in the first part, I'm going to talk about how can we understand online misinformation. Now, before using AI to reduce online misinformation, it's very important that we understand misinformation. Now, there's a very nice recent paper called The Psychological Drivers of Misinformation Beliefs and Its Resistance to Correction, published in Nature Review Psychology. And they talk about these kind of different factors that influence people to fall for fake news. So one of the things is lacking analytical thinking or deliberation. So lacking intuitive thinking. So if you don't have that kind of critical ability to analyze content, you might easily fall for misinformation. And then you have kind of cognitive failures. So this is where you kind of neglect sources or forget about the source, right? So think about a news article trying to use a media organization's logo. So something similar to the News First logo. And then you might mistakenly think that this is a news article published by News First, right? And then you have these kind of illusionary truth effects. So there are certain factors that will lead you to believe that it's true. So one of the thing is kind of familiarity. So if you see some fake news randomly many times or over a week, you might end up thinking, oh, I've seen this somewhere before, so this must be true, right? So this is kind of the illusionary truth effect. And then you have socio-effective drivers. So these are things that are driven by society and how you live in it, right? So one other thing is social cues. So you tend to believe stuff shared by your friends or shared by the people who are within your group, right? Or things that seem to be attractive to you. And then you tend to fall for things that drives emotional state and news content that includes emotional information. So think about a news article that says, if you follow these steps, you will not catch this particular virus. And then that kind of gives you this kind of emotional state to escape that particular virus. So then you tend to fall more for these kind of news articles. And then the worldview. So this is also very interesting. It's quite established in research that you tend to fall for misinformation that agrees with your political view or other values that you have as part of your worldview. Now, so we need to first understand how these kind of different societal factors or user attributes can actually influence how you fall for misinformation. So I'm going to talk about two studies. And the first one is looking at how comments and their content really influence how people, whether people trust online news or not. So this is a study that we did a couple of years back. And we basically looked at the composition of comments and then whether comments can influence. So the comments that are really supportive of the article's trustworthiness and comments that really criticize articles' trustworthiness can change how people perceive these articles, right? So we basically had two experimental conditions. So in one of the cases, you had this just the article, and then you had the article plus a bunch of comments. So the composition of these comments varied. So some of them were kind of criticizing the article's credibility, saying that, oh, this is fake news, you shouldn't be reading this. And then some of them were kind of believing what's shared in the article and they were kind of adding more information to it, right? And then, so what we found was quite interesting. So this is called, this phenomena is called conformity in the literature. And then what you can see here is if a majority is supportive or critical of the content, you tend to conform with the majority. So you tend to agree with the majority. Let's say you have 4 comments and all 4 of them are actually saying, so this article is fake, you shouldn't believe this, some things like that. So you're critical of articles' trustworthiness. So in that case, when users read this article, they also tend to agree with what the commenters are saying. So that's what you see here. So as the majority size increases, so this is kind of the difference between the majority and the participant, right? So if it's 0, that means we have a balanced sample. If it's 4, that means it's either a critical majority or a supportive majority. So in both cases, the person's likelihood to change their opinion to agree with the majority increases, but it's more pronounced with the critical majority compared to a supportive majority. So then we also looked at how their tendency to react to these articles change, right? So, so the reactions could be reacting to the article, commenting, sharing, or then going in and fact-checking that article, or reporting that article as fake news. So as you know, in platforms like Facebook, you can click on that flag icon and then kind of report so that the people can investigate this. So what we saw here was also quite interesting because, sorry, let me just go back. So in this case, you can see, so these are conforming responses, right? So when I say conforming responses, the idea is the user agreed with the majority. And when I say non-conforming responses, this is the user did not agree with the majority. So let's say the user thought that the article was real at the beginning, and then they ended up thinking that it was real as well, regardless of the comments of the majority. So, but what's interesting is when the user conformed to the majority, so conformed means change their opinion to agree with the majority, you can see they're more likely to respond. So they're more likely to react, more likely to comment, more likely to share, and more likely to fact check. So with the supportive majority, of course, so you think that it's real news, and then you're more likely to react to it, you're more likely to comment and more likely to share. But with the critical majority, so it's now fake news, right? So if the majority is critical, then the article should be fake. So then you are significantly less likely to react to it, significantly less likely to comment on it, and significantly less likely to share it, right? So this is an interesting observation because it shows that if the commenters are right on the article's trustworthiness, then it can really influence the subsequent viewers as well. Now, what's the takeaway here? Well, the takeaway is most of the social media platforms have mechanisms to organize comments. So it's no longer based on the recency. So if you go to social media platforms, comments are not ordered based on when you commented, but they are ordered based on popularity or a certain algorithm, right? But in the case of fake news, if we can organize these comments based on whether they're critical of the article's trustworthiness or whether they are supportive of the article trustworthiness, we can change people's opinions about these articles without directly telling them that article is fake or not. So this is kind of an interesting line of work. Facebook has done certain changes in their platform along these lines, but this is a very promising direction to play on. All right. So before I continue, I know I'm kind of going through a lot of content, but I'm also kind of happy to take any questions if you have. I cannot see the chat in this window, but I'll also spare like 15-20 minutes at the end of the talk for you to ask questions. So yeah, either would work fine for me. All right. So the second study that I'm going to talk about is looking at Twitter. So in this case, we are looking at a concept called homophily in political discussions on Twitter, right? So again, as you can see, so I have a citation of this work. The bottom of the slide, if you're interested, please feel free to read the paper. So homophily is described as kind of the tendency to make connections and interact more with people who are actually similar to you. So the idea is you tend to follow and connect with people who are similar to you in terms of your demographics, your political affiliation, or it can be your religion, or a lot of different factors, right? This phenomena had been kind of studied in online setup as well, but we specifically wanted to look at a case in Global South. So we were looking at this kind of political discourse in India. So in India, there was a huge political discourse. This was in kind of 2020, if I recall correctly. So in late 2019, they introduced this thing called Citizenship Amendment Act. So, which is to provide citizenship to people who have come to India from neighboring countries, particularly people who have escaped prosecution or feared prosecution in those countries. And but this act had an interesting point because it excluded Muslims from that particular provision. So anyone who had this, who fulfilled other criteria, but were Muslim, could not actually get the citizenship through this amendment. So this kind of led to a really fierce debate in India. So there was a lot of kind of political discussions happening in Twitter. and it also kind of led to violent protests there. So this was like an interesting discourse to study. So what we did was we collected a data set of tweets using the hashtag CAA from Twitter API, which we ended up kind of collecting nearly kind of 78K tweets. And we excluded tweets from kind of media houses, and then we ended up with this kind of nice data set. So here you can see like a summary of the user connections we had there. So we had roughly kind of 63K reciprocal follow connections, which means if you take two users, both of them follow each other. And then so then we also kind of had like kind of more unidirectional connections, which means it's just like one way. And so we were looking at follow, retweet, and mention connections. So you can think of it like a big network graph. So then what we did was we classified users into 3 political groups, and then 3 groups based on the content of their tweets. So the political groups were created based on their user profile, right? So the affiliations that they have. So we had like a kind of an annotation criteria, and then we had a manual annotation process to figure out the category for each of these users. And then we had then we got the average sentiment of their tweets, and then also classified them into positive, negative, and neutral groups. So here you can see through the entire discourse, we had more users who were pro CAA. So this was kind of users who were saying that CAA is good. You know, it was not really criticizing the act. But then we had kind of roughly 1/3 of the portion in anti-CAA camp. So the big, I mean, the important thing to note here is that there's a clear division. So this is like a very strong discourse. As you can also see that like most of the comments were negative. Like so most of these tweets that generated during the discourse had negative sentiment. So this is like a fierce debate. So then we did 2 types of analysis. I'll probably just explain the structural analysis, just talk about that one. But yeah, so the hashtag analysis and topic modeling details in the paper. So we use this kind of inbreeding homophily index, which has been kind of used to look at this problem. So there were kind of the 2 interesting things that we observed was so in both cases, especially when we look at the political camp of the user, you can see there's a lot of homophilic behavior there. So the users were significantly following other users who are actually having the same political affiliation, which kind of confirms the behavior of this kind of discourse, right? And it was a bit interesting. This is kind of the same thing in retweet space as well. So you were trying to retweet the people who express the same opinion. But the mentions actually had a bit of an interesting distribution. So we didn't see a lot of homophilic, so inbreeding homophilic behavior there. So this is what we kind of discuss as an interesting space for us to explore how we can create healthy discourse in an online space. So the key takeaways or the key observations in this study was that users' political dispositions mainly dictate how they connect and interact in online platforms, but mentions or the mention feature that we have in social space actually provide an opportunity for us to promote cross-ideological interactions. And similarly, although I didn't show the results of this, the common use of hashtags and interest in common topics is kind of another way so that we can promote cross-use interactions in these kind of platforms. Now, you might wonder why this is actually relevant to online misinformation. Well, then the idea is if you can create healthy discourse in an online platform, it's much easier to curb misinformation. Now, what I explained was actually kind of two straightforward examples or two studies that use data analytics and online experiments to understand how people share information in online spaces. Now, this is an interesting and important space, which can really benefit from computational technologies, so that when we start fighting misinformation, we have a very good understanding about how misinformation is spread, how misinformation is shared in online spaces. Okay, so that leads us to part two. So reducing online misinformation. Now, before talking about reducing online misinformation, we should talk about fact-checking, like, because fact-checking is one of the main ways of fighting misinformation online today. And you might have already seen these kind of websites. So these are kind of popular fact-checking outlets. So I have two examples. One is this ABC, RMIT ABC Fact Check, which is a fact-checking organization in Australia. This is a collaboration between the university that I'm currently working in, RMIT, and the Australian Broadcasting Corporation, which is the national news organization in Australia. And then PolitiFact, which is one of the famous fact-checking outlets in US. And then factcheck.lk, I think one of the most popular fact-checking websites in Sri Lanka as well. Now, most of these organizations are independent, and they try to fact-check critical news articles that are being spread in their local context. And most of these organizations do manual fact-checking at this point, which involves a lot of effort. Now, just to highlight that, I'll show you an example. Right? So this is an interesting example. It all starts with the particular social media post or a news article that is being shared online. Right? So this is a news article. Oh, sorry, this is a social media post that is being shared online. And then the fact-checking organization might pick this up because this has been shared so widely, and they will. So there are professionals who work in these organizations, so can be journalists or communication experts, and then they will start investigating whether it's true or false, and then they will publish another article in their website saying whether it's true or false. So in this case, it's false. So this particular photo was doctored. And then if you go to this link, you can see the actual fact-checking report. So in a fact-checking report, you need to talk about the origin of the claim, and then explain how you did the fact-checking, and then provide the verdict whether it's true or false. So in this case, so this is just a summary that I've extracted from the report. What they're saying is that this is not true, that they have spoken to the particular Melbourne tram company and then confirmed that there was no advertisement like that on the tram. And then they've also shown that a particular website that actually shows the original image. So this is the original image, and then this is the kind of edited image. It's like a silly example, but that shows the amount of effort that you need to put in to verify a piece of fake news. Now, the holy grail is making it all automated. Now, this is not as straightforward as we think, right? Because it involves a number of stages. So the first one is claim detection or checkworthiness and prioritization. So the idea here is you need to find different claims or different social media posts that you should be checking, because there's millions and millions of social media posts and articles that are being published online. So which ones you should be fact checking? So which ones are important? So this could be based on the popularity, based on how impactful that is to the society. So there could be different metrics, right? So the first process or the first stage of automated fact checking is actually detecting different claims, and then predicting their checkworthiness. So we call this kind of claim checkworthiness prediction problem. So you get like a statement, this can be an article or an image or a social media post, and then the model should predict whether it should be fact-checked or not. And then the second stage is evidence retrieval. So once you find a checkworthy claim, you should retrieve all the relevant evidence, because you need to support a fact-checking verdict with evidence. So for example, if you're talking about a census figure, you need to find the relevant census report from the census department to validate that. And then the third stage is veracity prediction. So a model would predict, given this claim, is it true or false? It might not be a binary in certain cases. It could be like a multiple classification problem, multi-class classification problem, where you would try to predict whether it's true, whether it's mostly true, whether it's in between, whether it's false, or whether it's kind of extremely false or really horribly false. So different organizations have kind of different different set of categories. But generally, the idea here is you try to predict the veracity or the final verdict that the claim should receive. And then the final part is explaining this to the user, right? So if we go back, so here in this kind of case, you have an entire article that's explaining this verdict. But if you just do this with the model, you'll only have a number or a class label. So you need to figure out a way to explain this to the user. Because if you just say to the user, this is the article and it's true, well, why is it true? So the user wants to know all this information. So that's what we call creating explanations in the automated fact checking. So there are interesting developments that can do all of these tasks, but they're not 100% mature. So it's very hard to kind of use them in real world pipelines. So we've also been looking at this final stage, that is presenting fact-checking information to the user, right? And we've been looking at kind of how you should be structuring a fact-checking report in screen-based interfaces and then also voice interfaces. And throughout a recent workshop that we've kind of identified different features, such as providing clarity on the final verdict and kind of having a clear, effective structure, and then also kind of developing trust towards the verdict. So how can you get the verdict to trust, get the user to trust the verdict, and then how can you personalize it based on the user characteristics? So these are kind of important things that you need to consider when you're creating fact-checking reports for different channels that should be directed at users. So how can you objectively test this? So we ran an online experiment with a computing setup that can automatically generate different types of fact-checking reports. And what we, so for example, here you can see, so the original barebone report does not have these kind of cool features here you have. So you might have things like a veracity indicator, you might have something like a summary, or you might have a logo that says this particular fact-checking organization is part of a global network. So it's kind of adding more credibility. Or you might try to organize everything more neatly so that the user can unpack it easily, right? And when we do this presentation information, what we observed was that it actually helps users to accurately interpret the relevant verdict. So it helps users to know whether it's true or false. And then we also observed that it reduces things like the click count and the scroll events and mouse movements, which means the users can navigate the report pretty quickly. So these are kind of promising results, and our next step is actually working towards the voice setups. We are also looking at capturing kind of the user interactions and user biases. and then using that information to generate personalized verifications that can reduce bias. So this is another interesting direction where we have conducted some preliminary experiments. And then, so this particular paper, if you're interested in, we try to characterize kind of different information processing activities. And then we try to build on this work and take it to the fact-checking space in the next phases. All right. So now that we talked a little bit about how we can present information effectively to the user, there are also a couple of other approaches that can help automated fact-checking. So one of the things is human-in-the-loop approaches. So in a human-in-the-loop approach, you're trying to use automated tools as well as online workers like crowd workers to generate fact-checking reports. So the idea is that, so I mentioned the AI tool pipeline, right? So these are things like machine learning, search and recommendation, and NLP tools. So once you have the fact-checking things, you could use input from these kind of AI tools as well as crowdsourced workers. So these crowdsourced workers are kind of, you can think of them as like an online workforce that can do tasks on demand, right? So these are kind of very simple tasks. So they can actually do tasks like the checkworthiness, claim checkworthiness ranking, and then truthfulness judgments. So what you can do is you can combine all of these two things together at an fact-checking expert level, and then generate the fact-checking reports, which kind of works really nicely. And there's a couple of works that have shown how we can use this kind of human-in-the-loop approaches to deliver effective hybrid fact-checking results. Now, you might think whether fact-checking is the only solution. Well, not really. There are other things that we can do as well. So one of the things, one other thing that you could do is creating online interventions. Now, this is an interesting study that was published in Nature in 2021. And they did a series of studies that showed if you prompt users to think about accuracy, that itself can help them to reduce their misinformation sharing behavior. So I'll just explain one of the studies that's in the paper. So they basically sent a message like this to Twitter users who have been known to share misinformation. So the idea was that they just asked them to rate whether a particular article was accurate or not. So this is just like a very brief thing that they sent. And then what you can see is once you send this one, for the subsequent 24-hour behavior, 24 hours, when we look at their news sharing behavior on Twitter, you can see they tend to share more of credible articles compared to other articles. So in here, the x-axis shows the actual trustworthiness of a news source. So for example, New York Times is more trustworthy compared to things like Western Journal. And you can see, so people tend to share more of trustworthy articles compared to these untrustworthy articles. So this is a really interesting observation that showed that online interventions can also be very effective in curbing misinformation. So these are takeaways for social media platforms. Okay, so we are coming to the end of the talk. Just a few more slides that talks about generative AI challenges and opportunities for misinformation, right? So the challenge here is that generative AI is giving so much opportunity for malicious users to quickly generate text-based, image-based, video-based misinformation. You might have seen this advertisement, which is a good example for using deep fakes, right? So imagine people having the power of creating deep fakes pretty quickly at large scale. this can be a disaster for online misinformation, especially because this is highly unregulated. And the other risk is that people will also have the ability to generate local content. So the local content appeals to local audiences in a very effective way that makes fact-checking a really difficult job. There's a very good report that I've put in here, from OpenAI and Stanford Internet Observatory that talks about these kind of different challenges if you're interested. And then what are the opportunities? Well, generative AI, especially with this kind of very good ability to understand text information and generate rich text information, you can do more reliable automated fact checking. And then you can use these technologies to make fact checking reports more accessible. So, which means you can create really good explanations without needing fact checking experts. And then you can report fact checking through different channels, things like audio-based channels, because now no longer you don't need to spend a lot of time creating these, creating outputs for these channels, right? And then you can make fact-checking more accessible by using very highly effective translation features so that you can make it available in different languages. So with all that, I'll end my talk. I'll just give you kind of 3 key takeaways. So the first one is online misinformation or really reducing online misinformation is very challenging, and it's a complex problem to tackle. And we need to develop really effective AI tools, as well as we need to get a good understanding about human factors at play here. So you need to create really good complex experiments to understand this problem. And the final thought is generative AI has a lot of opportunities and risks in this space. So we should be kind of paying a lot of attention to that nowadays as well. Okay, so before I wrap up, I want to thank quite a few people who have contributed to the papers that I've mentioned in this talk. So this include my colleagues and at the University of Melbourne and RMIT University. So George and Vaz are my supervisors from UniMelb. And I currently work with a bunch of people at RMIT, including Damiano, Mark as well. Especially Damiano is doing quite a lot of work with RMIT ABC Fact Check. So if you are more interested about the fact checking problem, please go and read his work as well. And also my other collaborators, Simo, Anthony, Flora, and Senri as well. All right, so that brings us to the end of this talk. I'm happy to take any questions. So we have 10 more minutes, so that should be enough time to answer some questions. All right. Let me stop sharing. Yeah, I also mentioned that, yeah, so these are the links to my personal website and then also the ADMS Center website. So if you want to read a bit more about this project, feel free to jump on. Let me see if I can see the chat. I hope everything was pretty clear.
So if you have any questions, you can raise hand, or you can unmute yourself and ask your questions, or else you can use the chat as well.
So we have a question from Professor Chandana. So he's asking whether there are any effective legislation being considered to deal with deepfakes and dis and misinformation. So at least I can comment a bit about Australia. So both Europe. So I think the most advanced region in this case is Europe. So they also already have a responsible AI legislation working group that's working towards laws in this space. As for Australia, we did a report from the ADMS Center to the Australian government, but we don't have effective laws in place to kind of fight this at the scale that it's progressing. It's very basic, like the legislation that we have here. So I think, and I don't know about the current situation in Sri Lanka, but I think we really need to work with experts from different areas because this is something that I've figured when I work with people in kind of these different disciplines as well, because they don't have a thorough understanding about the risks and the opportunities that are being provided by these technologies. So we need to work with them so that we can create effective policies and regulations for these problems. Yeah. Thanks. So if you don't have any more questions, I think we can wrap up in a bit. And I posted my email there as well. I'll maybe put it in the chat as well. So, okay, wait, we do have another question. So in the scenario of crowdsourcing for verifying fact-checking, how to account for the reliability or quantity and the reliability when using the AI interactive tool, any specific methodology? So Tarindu is posting, thanks Tarindu, that's a really good question. So I'll speak of the two different methods. So in terms of crowdsourcing, so there are certain techniques that we can use to ensure the quality of the annotations that we get from these platforms. So this can, so one of the most simple methods that we can use is using gold standard questions. So the idea is that you have, let's say, a validation data set that you have reserved for verifying these responses. So you try to inject these gold standard questions. So the gold standard question is like a ground truth question that you already know the answer for. And then you try to occasionally inject these questions into the data set so that you can gauge whether users or the crowd workers are actually responding accurately. There are also other techniques like task assignment, so matching workers with different types of compatible tasks. I have done quite a bit of work in that space during my PhD. So that's when you're collecting data from crowd workers or online annotators. But if you're looking at the AI tools, so this is one of the problems because you can do like offline evaluation, right? Like the standard evaluation that we do having the test and train set. But that's not really sufficient to kind of gauge the quality of an online deployment. Like we really have if you have a live deployment. So this is where you can use the human in the loop approach that I mentioned in one of those slides, right? So, let's say you have an automated fact-checking tool. So you keep an audit trail of your decisions, and then occasionally you get either experts or crowd workers to assess these decisions so you can give feedback to the model about how well it has done in terms of automated validation. So that's the kind of the standard way of looking at it now, because so things like concept drifts can also happen, right? Because misinformation is something that evolves over time. So misinformation that was 1 year ago is quite different to misinformation now, right? Because there's quite a lot of other things that has happened in the past year. So because of that, the model should be consistently trained on new information if you want it to work effectively. So that's why we don't see a lot of AI-based tools solely doing fact verification at this point, at least. So Tarindu seems to have a follow-up question. So he asks, so also in a data scarce environment, how can we train these deep learning models and validate? How to improve the performance of such models then in overall? So I wouldn't call, I wouldn't say that data is scarce in some of these cases, because we do have quite rich data set, at least in the text-based space, right? Because people have been working on the fact-checking problem for quite a long time. So at least in the text space, we do have quite a lot of good annotated data sets to work on this problem. So if you come up with kind of a new method to for problems like, for known problems like claim checkworthiness prediction or veracity prediction, for text problems, yes, there are good data sets, so that's pretty easy to work on. But for things like, let's say, video data prediction, if you want to assess whether a particular video contains misinformation or not, that's a really hard problem. So we don't really have good data sets to work on such problems. And in such case, you will need expert validation from people like fact-checking organizations. So that's why we really work closely with professional fact checkers in some of these projects. So we get a sample of outputs and then we ask them to kind of validate it with their own expertise, because that's what they do. But then the problem is their expertise is very limited. So you can't ask them to annotate thousands of outputs. So then you need to do really careful sampling of your outcomes or of your data for them to validate. Yeah, I hope that answered your question. All right, thanks, Darindu, and yeah, thanks, Kasun, as well. Yeah, yeah, feel free to write to me if you have any questions. Yeah, I'm happy to follow up.
Okay, so if you don't have any more questions, we can, I guess, conclude the session. Before wind up, I would like to express my word of thanks. Firstly, on behalf of IT and Computer Engineering Sectional Committee, we wish to express our sincere gratitude to the IESL President, Secretary, and staff. Our special thanks to Dr. Danola Hettiarachchi, who has given his precious time to conduct this event. And we are thankful to him for sharing his immense knowledge on AI with our engineering community. Once again, many thanks to enable this evening to have a successful event. Also, I'll take this opportunity to thank our organizing team of the IT and Computer Engineering Sectional Committee for helping us to arrange this public lecture. Uh, we are organizing this kind of events to uplift IESL in all aspects. Finally, I extend my big thanks to all the participants who make this event successful. Thank you, everyone. Have a pleasant day and stay safe.
Thank you all. Yeah, thanks for your really interesting questions. And yeah, thanks for having me here. It was a real pleasure. And I hope to keep in touch with you all. And yeah, thank you.
Thank you, Dr. Danuda.